Hello again. Quick video this time about upgrading our customer API demo from .NET Core 2.2 to 3.1. As always, you can find the repo. There are two folders, Core 2 and Core 3, that represent .NET Core 2 and .NET Core 3 respectively. So here is the methodology that we found works pretty well. We haven't had much luck with in-place upgrades. It's fairly frustrating because many things have changed from 2 to 3 that are breaking changes. So generally what we find is create a new project structure alongside the old one, typically in a parallel folder tree, create the solution and projects, rough out your code structure, add in your standard NuGet packages for quality and security, and then start customizing, particularly the startup, which is probably the major change, program and startup, and then selectively cut over the controller and other libraries one at a time. And as you go, you're going to have to not only upgrade your NuGet packages, but in some of the cases, the Microsoft and other vendor NuGets have made significant changes from 2 to 3, often to accommodate the new version of C# and leverage its language features and its performance features and so on. And then as you go, a piece at a time, test to make sure that your web API or your website or whatever it is still works. So let's dive into some code. Okay, let's start with program.cs and take a look at the changes to that, and then we'll do startup, and then I'll point out some things in the controllers, and pretty much everything else is the same as the other demo. So the first thing that is important to notice is that we've gone from having a web host builder to a generic host builder that you pass args into, and you do a build and then a run, which means that all of your action is essentially happening in Create Host Builder. So you can see in Create Host Builder that we are creating a default builder, and then we're adding in a web host stack, and we're doing that by using startup and pointing to our startup class, which is startup CS. So it's a little different, but the syntax is slightly different because now we're using a generic builder and we are going in and adding configure web host defaults. So you're always going to create a default builder. And if you're building a Windows service or a Linux service, you'll use the .configure method that goes with that. And so because these are expressive, right, you can chain one after the other. In other words, you can have different startups that have different code for different kinds of application components. But in this case, we're doing a pure web API, Swagger, and so we only need to tell it that we're going to be configuring a web host. We want to use the defaults, and then we want to override anything we want to override by using our startup class. So let's go to startup CS and take a look at some of the differences there. Probably the most important differences are that Microsoft has rearranged some of the namespaces, but have no fear, by default, these namespaces are added to your program and startup and controller classes automatically. And so for your intents and purposes, other than adding in your own customizations and whatever additional system libraries that you need, you're pretty much set to go. And then Microsoft from 2 to 3 went from sort of a custom Swagger implementation to OpenAPI. And so when you add Swashbuckle, which is the Swagger OpenAPI helper for .NET Core, it now adds OpenAPI models instead. And we'll see how that manifests itself. If we look at the construction, we're going to inject configuration, and configuration is injected by our host builder. And we're going to hang on to our configuration in a variable so that we can use it throughout our startup chain. And the next most probably important block that you're used to is configure services. So let me see if I can get this framed well. And in configure services, this is the familiar pattern of adding services to our service chain. And by default, all of the services that you add in here are going to be added with the appropriate scopes, singleton, shared, instance, etc., for the ones that are pre-provided, like services add logging. So you can see that I'm using the log builder and plugins that I was using before, which are console and debug. The minimum set level is still fundamentally the same. The syntax or grammar is slightly different, but I'm setting up my logging so that I have debug logging for Visual Studio and console logging for my web host. Most web hosts in the cloud read standard out and standard error. And moreover, if you use logging library that conforms to IDLE, for example, the Microsoft Extensions logging package, which is the default in .NET, but you could use Serolog if you want or whatever, it is going to correctly categorize those logs. And those in Azure are collected by App Insights. And on other platforms, they'll be collected by whatever the collector is. But the point is, because these modern logging libraries log to the IDLE convention, and you, throughout your code, as you say, log information, log warning, log error, those things will be properly reflected and parsed by whatever tool is doing the analysis. So in my case, I'm on Azure, and so App Insights is my tool. I'm going to add controller services because I'm doing a web API. I really don't need to override any of the default behavior, but if I did, I would use an expression builder just like I used for add logging. And I'd use what we call an arrow function that is an anonymous function that defines some behavior, and you inject the relevant host variable into it at the left side of the arrow, and you do things to it or with it in the expression that bounds it. But in this case, for add controllers and add health checks, I really don't have to do anything. For my cores header, you can see that, in fact, I am using the injection pattern to get an anonymous function. And within that anonymous function, it turns out that add default policy, and there's add custom policy, add default policy, all different things, but they all take this anonymous function syntax. So then we're going to add services add MVC. And the reason we're adding the MVC service is twofold. First, because we're exposing OpenAPI, which means I want it to serve up pages. And it turns out those things are built on the MVC framework. And secondly, because like in my previous demo, I want to inject the global exception filter. And it transpires that the way you do that now is the arrow function that injects the appropriate object into your anonymous function and allows you to do things like filters.add and my global exception filter type, which is unchanged from version 2 to version 3. The implementation of Swagger has changed. Again, it now implements the OpenAPI standard. And why is that important? Because if we are behind an API gateway, like Azure APIM or Apigee, or I'm using tooling like on swagger.io or openapi.org, I want to make sure that the JSON that's generated is machine readable in the updated format. So I got a little fancy in my demo just to show you how it could be done. And so let's just kind of briefly walk through add Swagger Gen and sort of show you what I'm doing. So again, anonymous function that injects the swag object. You can call it anything you want using an arrow function. And within that arrow function, I am setting the version that as it will appear in the documentation. I'm creating a new OpenAPI info object, and I'm creating the properties of that, and so on. So having done that, I want to set control over how my document will be generated. And in this case, I am adding a page for common functions as well. And we'll see what happens when we run that. We're actually going to end up with 2 sets of pages. And then I've enabled XML code comments. And so this is the new style of figuring out where those are. And then we have the other half of the configuration coin, which is not that different from version 2, but there are subtle differences in how some of these things are structured, and also the order in which they're structured in. So it's worth visiting. Parenthetically, you'll notice that I have done what it recommended when I syntax checked, added the syntax checkers and validators to my project. And when I do that, it says, you know, I really ought to check to make sure the things I'm being passed by injection actually exist. I know of no case where that would not be true, because it's being called from inside a builder, and the builder does dependency injection, and so it should always be true. But the linter will nag about it if you leave it out, and it's a good practice anyway. So the next thing is you want to hoist the is development check fairly high into your app building stack. You'll notice we are using HTTPS redirection. So if my site host is capable of HTTPS and someone comes at me with HTTP, we will automatically redirect to HTTPS. If my host does not expose HTTPS as an endpoint, then it won't. Very useful. Use static files. As many folders and files as you want to be in the static file path. And you can see that underneath that, I have in fact said use static files. I provided a physical file provider. Again, there's a bunch of different file providers I could have used. And having done that, going to combine the directory path for assets images using path combine. Little reminder, path combine takes any number of arguments, and it works automatically correctly on Windows or Linux, so the right / or /. And then we combine it with the logical path string. So that's a new operator on ASP core that takes relative paths. And so this entire thing will glue together a static file provider that tags assets images specifically. And that is a nice thing. And I can do that over and over again. So I can do my JavaScript and I can do my CSS as well. And I can set an image path. This is less than obvious in 3.0, but essentially the injected environment has a variable called web root path. And it resolves to the root of your website correctly, at which point you can make into a path. Then I say, okay, I want to enable Swagger. So if I just say app use Swagger, I'll get the JSON generated to the path in my website, but I won't get the UI. And that's pretty similar to how it worked in 2.2, except in 2.3, I have a lot of fun things I can do in Swagger UI. We're going to enable routing, which means that we will be using the route attributes on our controllers and methods. We'll be turning on authorization. In this case, since I didn't configure it, it's there, but by default set to anonymous. I tell it that I want a CORS handler in the stack, and parenthetically the builder will put these, generally speaking, in the order that is required. And so you can be a little sloppy in the order you build these, but this is something that an order that I found that works, so I'm pretty happy with it. And then I say, okay, I want to set up some endpoints. And so when I call map controllers, it's going to absorb all of my routes on my controllers and methods, and it's going to make a route table. And then I'm saying, in addition to that, I would like it to respond to the health check inquiry on the endpoint health checks. And we'll show you how that works too. So that's the change, not amazingly different than 2.0, but enough different that if you just tried to cut the code over without kind of building it up from the ground up, you'd be very frustrated. And so that's what I did, especially for the services work and the app, is I let it create the default ones in my new 3.1 LTS project, and then I started selectively cutting and pasting. And of course, I had to use a certain amount of coding by Google to understand how some of these changed. But all in all, I got my startup kind of the way I wanted it. So let's run the app and kind of see what it looks like. And I'll show you some interesting facts. So I'm running this in my Visual Studio, which I've told it to navigate to Swagger index.html, which is the default path to your OpenAPI UI. You can override that in your startup, but in this case, what I've done is I've imposed my own style sheet and I have injected our logo in front of the label. And you can see that the new Swagger has some subtle changes, but you'll notice that the various properties and things that I set in my startup now show up on my page, and you can see that my 4 methods are exposed just as they were before. The methods themselves haven't changed. The presentation has changed ever so slightly, and you can, because it portrays the schemas a little differently, but fundamentally the same metadata is available. 2 more semi-annoying things. When you do a get, it doesn't automatically put it into try it out mode, which I find fairly irritating. You have to click try it out, put in your in this case, the search text for the person I'm looking for, and then it executes. Parenthetically, the reason for that is one of the options is expose the documentation, but you can prevent from executing any of the methods. So it'll hide the try it out button. It won't accept post requests to the page, things like that. And that's the underlying reason why that's kind of changed. The other thing that I've done, which kind of took me a while to figure out, but I'm showcasing in this demo, is that if you have a single web API project, you can actually break it into multiple APIs with some clever naming, and I'll show you how that works. And so here is the common API that I put on all my web APIs. So if I do a get on semantic version, I get a text stream back, text plain that with my semantic version ID in it. That's kind of a standard for me. I like doing that because it's useful for monitoring and so on. If I do a get on version, it actually dumps the subset of the assembly metadata, and you can look at the code to see how that works, but it puts out a little longer lunged thing. And then I have a demonstration of how to implement a health check endpoint. And when you execute that, you actually get the new, I should say, changed health check metadata back. And we'll visit that ever so briefly. But I just wanted to point out that not only is this much more machine readable, but in fact, many monitoring tools that are capable of pulling endpoints know how to interpret this out of the box. So Microsoft has adopted some common standards in building this response object that comes back, and we can look at that some more in the code. And of course, the other big difference is we are now emitting JSON in the OpenAPI style, and you can see that we have defined the components and metadata and schemas, and we've done, you'll notice the OpenAPI is a little more verbose, but the upshot of that is that if you use the new OpenAPI format and you have it generate either server code or client code from this OpenAPI using, for example, Swagger.io, as you've seen in other videos, you get a much better quality of scaffolding for your server project, or conversely, a more complete and ready to run client. Let's dive into a couple of changes at the controller level, and we'll start by looking at the controller for common, which again is emitting our standard endpoints. So get slash version, and get slash health. And I'll show you some changes. So unchanged is my habit of explicitly putting route paths on both the controller, but also on each of these. So the inferred path here is we add nothing to the path, and so calling a naked get on the root slash gets you the semantic version string. And you can see that I've adopted the habit of produces response type. Hypothetically, in this configuration, this.ok will take this JSON datagram and return it in the format that they asked it in. Again, because this is a simple string return, the terminal type here is a string. It will default to text plain. But I can tune that. So if I always want to return JSON, as in version info, I can actually explicitly say, I'm only ever going to return JSON from this method. So you can come at me with whatever you want, but you'll get an error if, as part of your accept in the request headers, you specify something I don't support. I'll actually throw an error. And I actually think this is a nice addition if you have something where you want to be ultra picky about the type of response. And I have an earlier video that shows how to return an image from WebAPI. And here it's definitely worth your while in the metadata to tell people right up front what your image will, what it will return. More importantly, though, in your Swagger JSON and Swagger UI, you'll get a much nicer user interface because you're telling it, I want the output of this to be JSON, or I want the output of this to be image ping, and it will very cleverly do the right thing, and it does a really nice job of formatting it. And of course, you can adjust that by injecting your own style sheets. So here is the health check endpoint. And here, again, reference to root, we are using /health. We're explicitly saying we're going to return JSON. And now there's two possible service codes that health check result, the appropriate thing that you should return in Microsoft Extensions Diagnostics Health Checks, is a lot more explicit. There are two major dictionary collections that are returned. They're both in the form of string object. It also returns an exception if there is one. And so just for fun, what I've done is I have injected my assembly information, which I scoop up in my program metadata property, which actually goes through and does the self-assembly reflection and gets the header metadata and then assigns it to a nice, easy-to-use data structure, and in some cases doing a little format. So I've got a little info block. That's very handy. You'll notice that I'm including the file and semantic version. I'm making a fake exception just to show you what it looks like in the output. I'm making a dictionary of dependencies and their relevant statuses. And that is worth doing because if you have a web API and it needs storage and it needs a database and it has to call another service, we want to be able to very clearly communicate which of those things is unhappy, or if they're all happy, that they're all happy. And so the upshot of that is we combine our dictionaries into one dictionary. So that's the nice thing about canonical formats like string object, is they're nestable. And so by convention, I'm using information for the information block and dependencies for the dependency block. And then I build a health check result. And I basically say, look, if there wasn't any exception, then I'm going to return a healthy result. Otherwise, I'm going to return an unhealthy result. And I'm going to pass in my data dictionary, my exception, if there is one, and the product name. And that's all part of the health check result schema. And then for logging purposes, I'm going to serialize that health check result and write it either to log warning or log information. And then what is expected that you'll return from your health check endpoint is the health check result. Let's go look at our friend, the customer controller, and see what's changed. I'm on version 3 of my customer controller, and so my route is assumed to be starting at root, and it's v3 person. So in the actual URL, it'll be /v3/person as my route. I declare kind of universally at the top level that I'm always going to be outputting application JSON and nothing else. This may or may not be a good thing for you to do. And then in the attribute API Explorer settings, you set a group name. In this case, we're setting the v3 group name. And in the case of our common schema, we're setting a name of common. And the upshot of that is what the UI will use to know which endpoints or operations belong to each one of our groups. And so this is how you can actually have multiple versions of the same API, or like I habitually do, have a common schema and the actual operational schema, and they get separate swaggers, which is nice because it's a separation of concerns. But more importantly, it allows me to say from the outside world, I'm not going to expose the Swagger common path, but I am going to expose the Swagger v3 path. And so that gives me granular control. So I can group APIs at the controller or method level into groups, and then they'll have unique paths. And so not only will I have the side benefit of multiple Swagger pages, but I'll also be able to set policies on, say, my web application firewall, my API gateway, whatever, about who can see the API information based on that route base. So that is a super nice thing to implement. And it opens the door, for example, if I wanted to ship v4, I could make a new group, call it v4, have it rooted in /v4 person, and I would get a v3 API and a v4 API and a common API. And that's a really good thing to do. Other than that, not a whole lot has changed. We are still constructor injecting our logger. DI, of course, is doing that work for us. I've gotten a little more methodical about produces response type. And I am being pretty explicit about the kind of responses they're likely to see. So notice that in the happy path, I can actually spell out explicitly rather than Swagger having to infer what my return type is. And that's a nice thing. But I can also say, look, I will kick you back a 400 error if I hate you. And if I can't find the ID you're looking for, I'll kick you a 404, right? So we can produce response type that shows up in the documentation, it shows up in the JSON, and it makes your APIs a lot easier to use. So in this case, the path to this is whack v3, whack person, and then parenthetical ID. And when you do that, it does the obvious thing of going and getting the person with that ID. And if it doesn't work, then it will throw the appropriate exceptions that are managed by our global error handler, and you'll get back the 404 you expect. Here's the same thing for search. You'll notice we're amending the path with a static path element and a dynamic placeholder. And so on and so forth. So the bottom line is .NET 3.1 LTS stands for long-term support. It is a much more robust implementation of .NET. It's typically a lot more memory efficient. It's screamingly faster. And they added a lot more flexibility for both web designers and web API designers so that you can have a lot more granular control if you want it, but that the defaults are all reasonable. And so you can go get this code off my GitHub and drill into it and use the examples when you're building out your own APIs and websites.